we live our lives online, right? And we expect everything to just work. Your banking app, your favorite streaming service, when one of those goes down, it feels like our whole digital world just grinds to a halt. So, what's really going on behind the scenes when a site or a service just vanishes?
Okay, so picture this. Your website or your service, it suddenly slows to a crawl. It's totally overwhelmed. And you've got this one huge question. Are you being attacked? Is someone malicious trying to take you down? Or did you just get incredibly, wildly popular? Is it a good thing or a bad thing? It's a super important distinction, and we're going to dive right into how you can tell.
So to really get to the bottom of this, we kind of have to take one step back. We need a basic framework. Like when people throw around the term network security, what are we actually trying to protect? What are the goals? Turns out it's simpler than you might think. It really boils down to three main things.
All right, so the experts have this model they use, and it's called the CIA triad. And yeah, I know what you're thinking, but no, it's not that CIA. This one stands for confidentiality, integrity, and availability. Think of it as the three-legged stool of network security. It's the absolute foundation for figuring out what we're protecting and why.
Let's make this super simple. Think about email. Confidentiality? That just means only you and the person you're sending it to can read the message. Simple. Integrity? That means the email doesn't get messed with along the way. And then there's availability. And this is the big one for us today. It just means the email server is actually working when you need to send or get an email. And it's this one, availability, that gets hit by what we call denial of service attacks.
Okay, so how does someone actually mess with a service's availability? Well, one of the most classic ways is something called a flood attack. And it's kind of clever, actually. It takes advantage of the very polite, very normal way computers talk to each other to start a conversation.
So in a normal world, when your computer wants to connect to a server, they do this little dance called a three-way handshake. It's just like a quick phone call. Your computer sends a message, a SYN packet. That's basically it saying, hey, you there? The server gets it and replies with a SYN-ACK, which means, yep, I'm here, I hear you. Then your computer sends a final ACK. Awesome, I hear you too. Boom, the line is open. Super polite, super efficient.
Now, here's where things get nasty. An attacker totally breaks this polite conversation. They send thousands of those initial hey you there messages, often from fake addresses. The server, being polite, answers every single one. Yep, I'm here. And then it just waits. But that final confirmation never comes. The attacker just ghosts them. So now the server has thousands of phone lines on hold for callers who don't exist, and its memory fills up with these half-open connections until there's no room for any real users. That is a SYN flood.
So you might be asking, how in the world do you fight back against something like that? Well, a bunch of smart engineers came up with a really clever workaround to stop servers from getting totally swamped by all these ghost callers.
It's a little something called a SYN cookie. The idea is pretty cool. When the server starts to feel overwhelmed, when its waiting list is full, it switches tactics. Instead of using its own precious memory to remember every single request, it sends back a special kind of encrypted cookie. It's basically telling the client, hey, you remember the details of this conversation for me. If a real, legitimate client gets that cookie and responds, the server can use it to rebuild a connection without having had to remember a single thing. It's a brilliant trick, right?
Okay, but, and this is a huge but, there's a catch. This trick isn't a silver bullet. Just look at this quote right from the Linux kernel's own documentation. They say that sync cookies seriously violate the protocol. It's a hack. It's a last-ditch effort that can break other, more modern features and actually slow things down for your real users. So yeah, it keeps the server from crashing, but it's definitely not a mode you want to be operating in for very long.
And this is where it all comes full circle, right back to our original question. Because when your system has to resort to using these SYN cookies, it spits out a warning message in the logs, and you'd think that message means one thing, but it might not be what you expect.
So if you're a sysadmin, you're looking at your logs and you see this exact message pop up. Possible SYN flooding, sending cookies. I mean, your first reaction is probably to sound the alarms, right? You think, we're under attack. But hold on, because that's not always what's happening.
And here's the absolute key takeaway. That exact same warning message can be triggered by a massive wave of, get this, real users. It could mean your app just went viral, that your service is so popular that tons of legitimate people are all trying to connect at once, faster than the server's default settings can keep up. What looks like an attack could actually be a sign of incredible success.
So what do you do? Well, a smart sysadmin doesn't just start blocking traffic. No, they investigate.
And they realize they can actually tune the server to handle a bigger crowd. You can go in and adjust these key parameters. Think of it like this. You're just making the server's front door and waiting room bigger. You're giving it the capacity to welcome that huge, enthusiastic crowd so it doesn't have to use those emergency performance-killing SYN cookies. So, when you step back and look at the whole picture, what's the real lesson here? It's that running a modern service, a modern network, it's all about this constant, delicate balancing act. It's a tug-of-war between security and performance.
You see, real network security isn't just about putting up a giant static firewall and calling it a day. It's a living thing. It's a dynamic process. It's about really knowing your traffic, constantly tuning your system, and most importantly, being able to tell the difference between a real threat and just a massive crowd of fans. Because one of those is a problem you block, and the other is a challenge you happily scale up to meet.
And that really leaves us with one final big question to chew on. In this world where we depend on these online services for literally everything, we have to constantly ask ourselves, where do you draw the line between ironclad security and that fast, seamless, amazing user experience that everybody expects? That right there, that's the tightrope that every single online service has to walk today.